All right, let's develop a third rule for exponent. If you were to simplify 2 to the third raised to the second, this rule could also be called the exponent of an exponent. So this is the exponent of another exponent. So based on what we know about exponent, if I have a 2 here, that 2 is telling me that this number here can be multiplied by itself, 2 of them. Okay, now if I do that, this brings me back to the first rule for exponents, which will say that add the exponents, because this is a product of 2 numbers that have the same base. So that gives 2 to the 6. Then I realize that the exponent of this exponent of also means multiply. So if I have the exponent of another exponent, that means this exponent of this exponent could mean this exponent multiplies this exponent. So let me find out if that gives the same answer. So if I have 2 to the third of another exponent, is it the same as 2 to the third? And we multiply the exponent times only the exponent? Okay, let's find out. This gives me 2 to the 6. So I get the same answer. I can make a conclusion. That conclusion can now be the rule 3 for exponent that can say, if I have any base number a to the exponent of m, and I have to multiply by another exponent n, this is just the same as the base number a. Exponent of exponent means multiply the exponent, and that is my third rule for exponent. All right, let's take some examples of this rule. Let's simplify. Okay, so 1, let's simplify 2 to the exponent of a half raised to the exponent of 2. Let us simplify 3 to the exponent of -2 raised to the exponent of 4. Let's simplify 5 to the exponent of x to the exponent of 2. Okay, so the rule says multiply the exponents. So right here, I want to multiply the exponents. Multiply the exponents. Okay, so I keep the base number the same and I multiply the exponent. If that is what I am doing, then here I have my base number is 2. I keep my base number of 2. Then I multiply a half at the exponent level. Okay, this base number sits still. At the exponent level, I multiply a half times 2, and 2 is the same as 2 over 1. When I multiply a fraction by a whole number, I want to put a denominator of 1 under that whole number. So this is the same as 2 to the exponent. When I multiply fractions, I multiply the numerators. 1 times 2 is 2. Fraction bar 2 times 2 is 2. So at the exponent here, I have some numbers that could simplify. Okay, so I can go below and say I have my base number of 2. Now 2 divided by 2 at the exponent is 1. So I can leave my answer like that until I learn another rule that can tell me how to write 2 to the exponent of 1. But we have seen this already. 2 to the exponent of 1 is just the same as 2. Okay, so moving on. Base number is 3. I keep the base number. I multiply the exponent. -2 times 4. The goal of this video is to learn how to simplify using the exponent of exponent and not how to multiply integers. Multiplying integers is already a prior knowledge for this lesson. So keep the base number of 3, and then we do -2 times 4, that's -8, and you can leave the answer in exponent form like that. Most of the time they will say leave your answer in exponent form. So we have a base number of 5, and then at the exponent I'm doing x times 2. So the The exponent is a variable. X times 2 is 2x, so my exponent is 2x, or 2 times x, which is the same as 5 to the exponent of 2x. And you can leave your answer like that. Okay, and so that is how we apply exponent of exponent rule. So that is why this is called the exponent of a product. Inside the parentheses, we have a product, 2 times a. So this is simplified as the exponent distributes itself to this coefficient of 2 times the variable a to the second. So you see this exponent distributes to the 2 and the a. So this will mean 2 raised to the third times x squared raised to the third. So 2 raised to the third is 8x to the 6. And remember, this will be exponent of exponent here, which we have already seen. We multiply 2 times 3, and that is how that becomes 8x to the 6. Let's take a second example. 3y to the second. This will mean 3 to the second times y to the second. Y to the 3 to the second is 3 times 3, and then times y to the second. 3 times 3 is 9, and then we have y to the second. Okay, so remember, rules for exponent just help us to simplify expressions in different ways, so we can use them in different ways as well. To simplify 2 over 3 raised to the second. Okay, these two are the exponent. This will come out as 2 to the second fraction by 3 to the second. Okay, and 2 to the second means 2 times 2, fraction by 3 to the second means 3 times 3, and so this is the same as 4 over 9. Okay, so remember, exponents just help us to simplify expressions and rewrite expressions in other forms. So let's take another example. How we just simplify x over 2 raised to the third. Is there any other way of rewriting this expression? Yes. This will come out as x to the third fraction by 2 to the third. X, we don't know what x is, so it will stay as x to the third, but we know what 2 is, so 2 is the same as 2. 2 to the third will be 2 times 2 times 2, and expression can become x to the third fraction by 2 times 2 times 2 is 8, so fraction by 8. So any number a raised to an exponent of 0 is equal to 1. Examples. Two to the exponent of 0 equals 1. If you simplify a number and it ends up with an exponent of 0, that just equals 1. Let's try 5 to the third divided by 5 to the third. This is the same as 5 to the 3 minus 3, which is the same as 5 to the 0, so that equals 1. That makes sense because whatever number it is, if you divide it by itself, you get 1. Okay, another simple rule for exponent is that any number raised to the exponent of 1 is just the same as a number without the exponent. Example, we had seen earlier that 2 to the exponent of 1 is just the same as 2. Any number base number a raised to a negative exponent is the same as 1 fraction by a to the positive exponent. How does this rule come about? Recall that we said if we have 2 to the exponent of negative 2 times 2 to the exponent of 2. This is the same as 2 to the exponent of negative 2 plus 2 from the product rule. So 2 to the exponent of 2 of negative 2, 2 to the exponent of negative 2 times 2 to the exponent of 2 is the same as 2 to the exponent of negative 2 plus 2 is 0. And we have also learned that any number raised to the exponent of 0 is 1. So 2 to the negative 2 times 2 to the positive 2 is equal to 1. So if this product is equal to 1, if we want to keep only this term on this side, then we will have to divide this term on both sides. So that is why we have 2 to the negative 2 is the same as 1 over 2 to the positive 2. Okay, so that is what brings the general rule that a negative exponent is the same as 1 fraction bar, then the positive exponent. So examples, if we solve a problem and we end up, example, write as positive exponent, right, as positive exponent. So if we solve a problem and we end up with 3 to the negative 2, can we write it as positive exponent? If we have 5 to the negative 1, can we write it as positive exponent? If we have 10 to the negative 3, can we write that as positive exponent? Okay, if we have 7 to the negative 4, can we write that as positive exponent? So let's write the positive exponent for these numbers. 3 to the negative 2, all you need to do is put a 1 at the numerator fraction bar, then write it as positive exponent. Put a 1 at the numerator fraction bar, then write it as positive exponent. But for this one, remember, 1 fraction bar 5 to the exponent of 1 is just the same as 5, so this is just 1/5. Can you imagine? You just found another way of writing the number, the fraction 1/5. You just found another way of writing the fraction 1/5. It's the same as 5 to the negative 1. Okay, so here 1 at the numerator fraction bar, 10 to the third. 1 at the numerator fraction bar, 7 to the fourth. Okay, that is how we can write a negative exponent to have a positive exponent.